Hello students, in this video I'm going to show you how to solve a couple of quadratic equations. This is practice for an upcoming exam. Take a look at these 5 equations. They're all quadratic equations. We know that because they have that x squared term, and they all have different configurations. Some of them have 3 terms, they're already in quadratic form. Some of them have the x squared term but no b term. Some of them have a odd b term. We're going to be taking a look at the best ways of solving these quadratic equations over the next few minutes. And let's start with the first equation, x squared minus 9x plus 20. As you recall, we had 4 different methods of solving quadratic equations: factoring, square root method, completing the square, and quadratic formula. Let's try to use each of these in turn. Well, I know that we can't use the square root method here. The reason is this equation happens to have a b term. The square root method, if you remember, requires only 2 terms, the x squared term and a constant term, so we can't use that. If you think about completing the square method, we also can't use that very easily in this problem. And the reason is that middle term, the b value, is odd. So we shouldn't use completing the square method. If you recall quadratic formula, that's a fairly long and involved process. So in order to forestall that, to prevent that, let's take a look at factoring and see if that works. We're looking for 2 numbers. A number that'll multiply together to give you positive 20, and that'll add together to give you negative 9. So the first step is to make a t-chart on the right-hand side of the paper. In this t-chart, we're going to try to take a look at all the pairs of numbers that multiply together to give you 20, and then we'll pick the one pair that adds together to give you negative 9. And you can see in this t-chart that we've listed all the factors that that multiply together to give us 20, and one of them adds together to give us negative 9, and that's negative 5 and negative 4. In order to use that factoring property, this is the one we're selecting, by the way. In order to use that factoring property, we're going to create 2 different binomials that are multiplied together that are equivalent to the trinomial that you see here. And as you can see, we replaced x squared minus 9x plus 20 with x minus 5 times x minus 4. And I'm telling you that this product of 2 binomials is going to give you that trinomial. Now we know that we have 2 things being multiplied together, 2 binomials. If we know that this times this is equal to 0, then by the zero product property, we can say, well, x minus 5 is going to have to be equal to 0, or x minus 4 is going to be equal to 0. We need to solve for both cases. So we'll do a method that I called in class split and solve. We'll take a look at all the different possibilities for x minus 5 and all the different possibilities for x minus 4. And again, we refer to the zero product property, wherein we take both factors, and we set them equal to 0. If we solve both, we get 5 is equal to x and x is equal to 4. So we have 2 values for our solution. We have x could be equal to 5 or x could be equal to 4. The way in which we represent that is to put x equals solution set bracket 5 comma 4, close solution set bracket. This is the solution set, the 2 different possible solutions for x. All right, let's take a look at the next problem. We have 3x squared is equal to 60, and when looking through our methods, one of them stands out as probably the best case scenario for this particular equation, and it's not factoring, even though we could try to do factoring. And it's not completing the square, and it's not quadratic formula either. It's actually square root method. The reason I select square root method is because, simply, there is no b term. There's no term with just an x attached to it. So we'll try to use the square root method, which requires us to isolate the x squared and then take the square root of both sides. So as I said, the first thing I'm going to do is try to isolate the x squared. In this case, that means I'm going to divide both sides by 3. So as you can see, we made this equation a little bit easier. We went from 3x squared equals 60 to x squared is equal to 20. We divided both sides by 3. Now what we can do is take the square root of both sides. One thing to remember is that when you take the square root of a number, there are 2 answers, positive and negative. So you can see we square rooted both sides, and the answer became x equals radical 20 and negative radical 20. Now, keep in mind, every time you have a radical, which is not a perfect square, you need to look inside of it to see if there is a perfect square factor which you can take out. This is called simplifying the radical. In this case, 20 has a perfect square that is its factor, which is 4. So what we're going to do is represent these radical 20 and negative radical 20 as the product of a perfect square and a non-perfect square. Here's how that looks. And you can see that I split it into the perfect square and the non-perfect square for both cases. Now I'm going to evaluate the square root of 4, and I should get 2. So there you have it. We have the two different answers, which are completely simplified radicals. Keep in mind, anytime you have a radical, you need to try to simplify it as much as possible. Try to find the perfect square that goes into it. All right, let's take a look at the third problem. All right, up until now in your class, I haven't shown you a method of factoring an equation like this, which is a quadratic with a leading coefficient of something other than 1. So as of right now, we'll skip this. If you're a little bit more savvy, if you know how to factor something like this, you might be able to do it, but I haven't shown you yet. I also can use the square root method for previously stated reasons. There's a b term. I could try to complete the square, but completing the square is really only very useful when you have an a value of 1 as well. So we're going to have to skip that. Unfortunately, we're going to have to do our last resort, which is the quadratic formula. Keep in mind that the quadratic formula is a totally valid method of solution, and it is fairly straightforward. The only problem is it takes a lot of steps. So let's get into it. As I've told you in class, the Common Core High School Math reference sheet, the one that you get with the Regents exam, actually has the quadratic formula on it. So you do not have to memorize that. That is something that we're going to grab from here and paste into our workspace, and then we'll try to work with that. All right, now that we have our quadratic formula here, remember the first step, if you do recall, is to find the values of a, b, and c from the quadratic equation itself. And we can see that the quadratic equation has an a value of 2, a b value of positive 1, and a c value of negative 3. Those are the coefficients of x squared and x, and a constant, respectively. So on your paper, the first thing you're going to do is write down those a values and b values and c values, and then we'll try to substitute them into the quadratic formula. As you can see, I took all the values, the a value, the b value, and the c value, and I substituted them into the quadratic formula. Take a look and see if you can see where these numbers are coming from. We know that these two are the b value. We know that this is the a value, and this is the c value, and we also know that this is the a value. The next thing I'd like you to do is try to evaluate the piece that's inside the square root. 1 squared minus 4 times 2 times negative 3. You could try to do this by hand. You could try to do this using your calculator. Whichever one's your pleasure, just try to get it right. And as you can see here, there's no shame in taking the entire piece that's underneath the square root symbol and substituting it all into your calculator and pressing enter. That should give you the correct answer every time. Now we know that the piece inside of the square root, the radical, should be 25. All right, we made the problem a little bit simpler. We took negative times 1 and made it negative 1. We took 2 times 2 and made it 4, and we took this entire piece and made it into square root of 25. We can make this even simpler by evaluating the square root, and this plus or minus piece is just indicative of the fact that when we take the square root of any number, we should get a positive and a negative answer. So after this step, we need to split it into two different parts. Negative 1 plus square root of 25 over 4, and also negative 1 minus square root of 25 over 4. So you can see our split, and we can even draw a line between them here to represent the fact that there are two different answers. X equals negative 1 plus rad 25 over 4, x equals negative 1 minus rad 25 over 4. We still can do some simplifying though here. We know that 25 is a perfect square, so we can represent this as negative 1 plus 5 over 4 and negative 1 minus 5 over 4. And now we see we can simplify it even more. Negative 1 plus 5 is actually 4, so 4 divided by 4 gives us 1. And negative 1 minus 5 is negative 6, and negative 6 divided by 4 gives us, well, that's negative 1.5. Now we have our two answers, 1 and negative 1.5. Now we can represent them in a solution set. There are your answers. Let's take a look at the next one. All right, looking at this equation, you can see that the square root method is out first. And we know that square root method is out because there's going to be a b term. This 4x is going to be our b term. We could try to factor. We could try to complete the square. We could try the quadratic formula. So we'll try them in order. Let's try factoring first. And as you know, when you try to factor a quadratic equation, you need to put it into quadratic form first. So let's try to write it as an equation that says ax squared plus bx plus c equals 0. And hopefully you see how I did that. I subtracted 4x from both sides. I knew I got x squared minus 4x plus 2 equals 0 from that. Now that it's in quadratic form, we'll try to find two numbers that multiply together to give us the c term and add together to give us the b term. And here we run into a bit of a problem. We know that the only two factors of 2 are 1 and 2 versus negative 1 and negative 2. Neither of those pairs of factors are going to add together to give me negative 4. So our factoring method is out. we're going to have to use either completing the square or quadratic formula, and lo and behold, our b term is even. So we are able to use our completing the square method. So I'm going to use this one to show you how to complete the square. The first step in completing the square is to get the original c term to the other side. I just got this into quadratic form. Now I'm going to wreck it by taking that 2 and moving it to the other side. So you can see now I have x squared minus 4x on the left-hand side and just negative 2 on the right-hand side. Now what I'm going to do is I'm going to try to find the correct c term to make this into a perfect square trinomial. You should remember perfect square trinomials from our work in class. A perfect square trinomial is a trinomial that you can turn into a squared binomial. So I'm going to show you how to do that now. And as a quick reminder, I just want to remind you that a perfect square trinomial is a trinomial that can be rewritten as a squared binomial. Here's an example. This perfect square trinomial has terms such that it can be rewritten as a squared binomial. Remember, in order to get the c term, we're going to take this term and square it. In order to get the b term, we're going to add this term by itself. So in order to get the correct c term here, we're going to take the b value, we're going to cut it in half and square it. I'm going to show that on the right-hand side. And one handy quick formula to remember is b over 2 squared. We'll take the b term, which is negative 4, divided by 2, and square it. So negative 4 divided by 2 is negative 2. Square that to get 4. So the number that we have to add to both sides to get a perfect square trinomial is 4. And you can see I added 4 to both sides here. The reason I did that was because I want to turn this from a perfect square trinomial into a squared binomial. So now I'm going to take this perfect square trinomial and rewrite it as a squared binomial. I'm also going to combine these two numbers because they're like terms and I'm allowed to do that. Now you can see that I turned it into x minus 2 squared. I got that minus 2 from using an offshoot of the A&M method. I know that negative 2 plus negative 2 gives me negative 4, the b term. And I know that negative 2 times negative 2 is going to give me positive 4, which is the c term. I can rewrite that as x minus 2 squared, and I know that negative 2 plus 4 is equal to 2. Now I'm going to use an offshoot of the square root method. I'm going to square root both sides. Now, a less savvy math student might be careless and say, well, the square root of 2 is just the square root of 2, but you should remember that the square root of 2 has two answers, positive and negative. So now that we've separated this equation into two possibilities, positive radical 2 and negative radical 2, we can solve for x. So now that they're solved for x, we can rewrite this in the form of a solution set. And there you have it. You have the two solutions in a solution set, radical 2 plus 2 and negative radical 2 plus 2. Keep in mind that the reason that we did not simplify these square roots of 2 is because there's no perfect squares inside of 2. Let's take a look at the last equation. All right. Since this is not an equation we could turn into an equation, and we should, I'm going to turn it into negative x squared plus 5x plus 9 is equal to 0. There we go, a little bit more solvable. Now, the factoring method sort of goes out the window here because we never discussed a method of factoring with a negative x squared. There's a way to do it, but let's try to use another method for now because factoring is well understood. The square root method is also out because, as we spoke about previously, there is a b term. Completing the square is also difficult because the b term happens to be odd. So the quadratic formula is again the one I'm going to use. So let's copy that big formula from before and get started. All right, by now you should know the first thing we're going to do is identify the a, b, and c values, the coefficients of x squared, x, and the constant, which is 9. Once we have these values, we can substitute them into the formula and start solving. And as you can see, I substituted the a, b, and c values into the quadratic formula. Now I'm going to try to evaluate the piece that's inside of the square root. I once again turn to my trusty calculator, which evaluates the piece inside of the radical to be 61. All right, we check the 61 to see if it can be broken down at all, just like what we did with the previous problem. But 61 is actually a prime number. It has no factors, except for 1 and 61. So we cannot break this into a simpler radical. So we split it up and solve. And even though this seems to be a sort of messy answer, this looks like about the best we're going to do. The one thing that I'm going to do is divide negative 5 divided by negative 2 and 61, square root of 61 divided by negative 2 to take a negative out of there. But that's basically what it's going to look like. And if this looks like your answer on a test or a quiz or something like that, you'll be just fine. You'll get full credit. All right, hopefully this was a very helpful review of solving quadratic equations. Good luck studying.